Innovative methods of data collection. Let us consider some other innovative or modern methods of data collection particularly used by business house in modern times. They are extensively employed in market researches. Warranty cards. Warranty cards are usually postal-sized cards which are used by dealers of consumer durables to collect information regarding their products. The information sought is printed in the form of questions on the warranty cards which is placed inside the package along with the product with a request to the consumer to fill in the card and post it back to the dealer. Distributor or stone audits. Distributors or store audits are performed by distributor well as manufacturers through their salesmen at regular intervals. Distributors get the retained stores audited through salesmen and use such information to estimate market size, market share and seasonal purchasing pattern and so on. The data are obtained in such audits not by questioning but by observation. For instance, in case of a grocery stone audit, a sample of stores is visited periodically and data are recorded on inventories on hand either by observation or copying from store records. Store audit are invariably panel operations, for the derivation of sales estimates and compilation of sales trends by stores are their principal raison d'etre. The principal advantage of this method is that it offers the most efficient way effect on sales of variations of different technique of in-store promotion. Pantry audits. Pantry audit technique is used to estimate consumption of the basket of goods at the consumer level. In this type of audit, the investigator collects an inventory of types, quantities and prices of commodities consumed. Thus in pantry audit data recorded from the examination of consumers' pantry. The usual objective in pantry audit is to find out what types of consumers buy certain brands. The assumption being that the contents of the pantry accurately portray consumers' preferences. Quite often, pantry audits are supplemented by direct questioning relating to reason and circumstances under which particular products were purchased in an attempt to relate these factors to purchasing habits. A pantry audit may or may not be set up as a panel operation, since a single visit is often considered sufficient to yield an accurate picture of consumers' preference. An important limitation of pantry audit approach is that, at times, it may not be promotion devices produce a marked rise in sales. Consumer panels. An execution of the pantry audit approach on a regular basis is known to maintain detailed daily records of their consumption and the summary is made available to investigator on demands. In other words, a consumer panel is essentially a sample of consumers who are interviewed repeatedly over a period of time. Mostly consume panels are of two types viz. The transitory consumer panel. A transitory consumer panel is set up to measure the effect of a particular phenomenon. Usually such a panel is conducted on a before and after basis. Initial interviews are conducted before the phenomenon has taken place to find out the consequent changes that might have occurred in the consumer's attitude. It is a favorite tool of adverting and of social research. A continuing consumer panel is often set up for an indefinite period with a view to collect data on particular aspect of consumer behavior over time. Generally, all periodic intervals are maybe meant to serve as a general purpose panel for researchers on a variety of subjects. Such panels have been used in the area of consumer expenditure, public opinion and radio and TV listenership among others. Most of these panels operate by mail. The representativeness of the panel is relative to the population and the effect of panel for researchers on a variety of subjects. Such panels relative to the population and the effect of panel membership on the information obtained after the two major problems associated with the use of this method of data collection. Use of mechanical devices. The use of mechanical devices has been widely made to assess psychological impact and attitude. One of the prominent devices was psychogalvanometer. Motion picture camera and audiometer are the principal devices so far developed and commonly used by modern big business houses, mostly in the developed world for the purpose of collecting the required information. Eye cameras are designed to record the focus of yes of a respondent on a specific portion of a sketch or diagram or written material. Such information is useful in designing advertising material. Pupil-metric cameras record dilation of the pupils as a result of a visual stimulus. The extent of dilation shows the degree of interest aroused by the stimulus. Psychogalvanometer is used for measuring the extent of body excitement as a result of the visual stimulus. Motion picture cameras can be used to record movement of body of a buyer while deciding to buy consumer goods from a shop or big store. Influence of packaging or the information given on the label would stimulate a buyer to perform certain physical movements which can easily be recorded by a hidden motion picture camera in the shop, as four walls. Audiometers are used by some TV concerns to find out the type of programs as well as stations preferred by people. A device is fitted in the television instrument itself to record these changes. Such data may be used to find out the market share of competing television stations. Projective techniques. Projective techniques, or what are called as out interviewing techniques, for the collection of data have been developed by psychologists to use projection of respondents for inferring about underlying motives, urges, intention which are such that the respondent either resists to reveal them or is unable to figure out himself. In projective techniques the respondent in supplying information tends unconsciously to project his own attitudes or feeling on the subject under study. Projective techniques play an important role in motivational researches or in attitude surveys. Use of these techniques requires intensive specialized training. In such techniques, the individual's own view, his personality structure, his needs, tensions, etc. In the context of some pre-established psychological conceptualization of what the individual's responses to the stimulus mean. We may now briefly deal with the important projective techniques. Word association tests. These tests are used to extract information regarding such words which have maximum association. In this sort of test the respondent is asked to mention the first words that comes to mind. Ostensibly without thinking, as the interviewer reads out each word from a list. If the interviewer says cold, the respondent may say hot and the like ones. The general technique is to use a list of as many as 50 to 100 words. Analysis of the matching words supplied by the respondents indicates whether the given word should be used for the contemplated purpose. The same idea is exploited in marketing research to find out the quality that is mostly associated to a brand of a product. A number of qualities of a product may be listed and informants may be asked to write brand names possessing one or more of these. This technique is quick and easy to use, but yields reliable results when applied to words that are widely known and which possess essentially one type of meaning. This technique is frequently used in advertising research. Sentence completion tests. These tests happen to be an extension of the technique of word association tests. Under this, informant may be asked to complete a sentence, such as, persons who wear khadi are. To find association of khadi clothes with certain personality characteristic. Several sentences of this type might be put to the informant on the same subject. Analysis of replies from the same informant reveals his attitude toward that subject, and the combination of these attitudes of all the sample members is then taken to reflect the views of the population. This technique permits the testing not only of words, as in case of word association tests, but of ideas as well and thus, helps in developing hypotheses and in the construction of questionnaires. This technique is also quick and easy to use, but it often leads to an analytical problem, particularly when the response happens to be multidimensional. Story completion tests. Such tests are a step further wherein the researcher may contrive stories instead of sentences and ask the informants to complete them. The respondent is given just enough of story to focus his attention on a given subject and he is asked to supply a conclusion to the story. Verb projection tests. These are the tests wherein the respondent is asked to comment on or to explain what other people do. For example, why do people smoke? Answers may reveal the respondent's own motivation. Pictorial techniques. There are several pictorial techniques. The important ones are as follows. Thematic apperception test, TAT. TAT consists of a set of pictures. Some of the pictures deal with ordinary day-to-day events while others may be ambiguous pictures of unusual situations that are shown to respondents forms the basis for the investigator to draw inferences about their personality structure, attitudes, etc. Rosenzweig test. This test uses a cartoon format wherein we have a series of cartoons with words inserted in balloons above. The respondent is asked to put his own words in an empty balloon space provided for the purpose in the picture. From what the respondents write in this fashion, the study of their attitudes can be made. C. Rorschach test. This test consists of 10 cards having printed inkblots. The design happens to be symmetrical but meaningless. The respondents are asked to describe what they perceive in such symmetrical inkblots and the responses are interpreted on the basis of some predetermined psychological framework. This test is frequently used but the problem of validity still remains a major problem of this test. Holtzman inkblot test, HIT. This test from W. H. Holtzman is a modification of the Rorschach test explained above. This test consists of 45 inkblot cards and not 10 inkblots as we find in case of Rorschach test, which are based on color movement, shading and other factors involved in inkblot perception. Only one response per card is obtained from the subject or the respondent, and the responses of a subject are interpreted at 3 levels of from appropriateness. For responses are interpreted for knowing the accuracy F or inaccuracy F of respondents, shading and color for ascertaining his affectional and emotional needs, and movement responses to assessing the dynamic aspects of his life. Special features or advantages. Firstly, ILE sees relatively constant number of responses per respondee. Secondly, it facilitates studying the responses of a respondee to different cards in the LIEAF norms of each card instead of lumping them together. Thirdly, it elicits much more information from the respondent than is possible with merely 10 cards in Rorschach test. The 45 cards used in this test provide a variety of stimuli to the respondent and as such the range of responses elicited by the test is comparatively wider. There are some limitations of this test as well. One difficulty that remains in using this test is that most of the respondents do not know the determinants of their perceptions, but for the researcher, who is to interpret the protocols of a subject and understand his personality or attitude through them, knowing the determinant of each his response is a must. This fact emphasizes that the test must be administered individually and a post-test inquiry must as well be conducted for knowing the nature and sources of responses, and this limits the scope of HIT as a group test of personality. In view of these limitations, some people have made certain changes in applying this test. For instance, Fisher and Cleveland in their approach for obtaining barrier scope of an individual's personality have developed a series of multiple choice items for 40 of HTT cards. Each of these cards is presented to the subject along with 3 acceptable choices, such as knight in armor, barrier response X-ray, penetrating response, and flower. Natural response. Subject taking the test is to check the choice he likes most, make a different mark against the one he likes least and leave the third choice blank. The number of responses checked by him determines his barrier score on the test. Tompkins Horn picture arrangement test. This test is designed for group administration. It consists of 25 plates, each containing 3 sketches that may be arranged different ways to portray sequence of events. The respondent is asked to arrange them in a sequence which he considers as reasonable. The responses are interpreted as providing evidence confirming certain norms, respondents' attitudes, etc. Play techniques. Under play techniques, subjects are asked to improvise or act out a situation in which they have been assigned various roles. The researcher might observe such traits as hostility, dominance, sympathy, prejudice, or the absence of such traits. These techniques have been used for knowing the attitudes of younger ones through manipulation of dolls. Dolls representing different racial groups are usually given to children who are allowed to play with them freely. The manner in which children organize dolls would indicate their attitude towards the class of persons represented by dolls. This is also known as doll play test, and is used frequently in studies pertaining to sociology. The choice of color, foreign, words, the sense of orderliness and other reactions may provide opportunities to infer deep-seated feelings. Quizzes, tests and examinations. This is also a technique of extracting information regarding specific ability of candidates indirectly. In this procedure both long and short questions are framed to test through them the memorizing and analytical ability of candidates. Sociometry. Sociometry is a technique for describing the social relationship among individuals in a group. In an indirect way, sociometry attempts to describe attractions or repulsions between individuals by asking them to indicate whom they would choose or reject in various situations. Thus sociometry is a new technique of studying the underlying motives of respondents. Sociograms are charts that depict the sociometric choice. There are many versions of the sociogram pattern and the reader is suggested to consult specialized references on sociometry for the purpose. This approach has been applied to the diffusion of ideas on drugs amongst medical practitioners. Depth interviews. Depth interviews are those interviews that are designed underlying motives and desires and are often used in motivational research. Such interviews are held to explore needs, desire and feelings of respondents. In other words, they aim to elicit unconscious as also other types of material relating especially to personality dynamics and motivations. As such, depth interviews require great skill on the part of the interviewer and at the same time involve considerable time. Unless the researcher has specialized training, depth interviewing should not be attempted. Depth interview may be projective in nature or it may be a non-projective interview. The difference lies in the nature of the questions asked. Indirect questions on seemingly irrelevant subjects provide information that can be related to the informant's behavior or attitude towards the subject under study. Thus, for instance, the informant may be asked on his frequency of air travel and he might again be asked at a later stage to narrate his opinion concerning the feelings of relatives of some other man who gets killed in an airplane accident. Reluctance to fly can then be related to replies to questions of the latter nature. If the depth interview involves questions of such type, the same may be treated as projective depth interview. But in order to be useful, depth interviews do not necessarily have to be projective in nature. Even non-projective depth interviews can reveal important aspects of psychosocial situation for understanding the attitudes of people. Content analysis. Content analysis consists of analyzing the contents of documentary materials such as books, magazines, newspapers and the contents of all other verbal materials which can be either spoken or printed. Content analysis prior to 1940s was mostly quantitative analysis of documentary materials concerning certain characteristics that can be identified and counted. But since 1950s content analysis is mostly qualitative analysis concerning the general import or message of the existing documents. Content analysis is a central activity whenever one is concerned with the study of the nature of the verbal materials. A review of research in any area, for instance, involves the analysis of the contents of research articles that have been published. The analysis may be at a relatively simple level or may be a sub-DLC one. It is at a simple level when we pursue it on the basis of certain characteristic of the document or verbal materials that can be identified and counted, such as on the basis of major scientific concepts in a book. It is at a subtle level when researcher makes a study of the attitude, say of the press towards education by feature writers. Collection of secondary data. Secondary data means data that are already available, i.e., they refer to the data which have already been collected and analyzed by someone else. When the researcher utilizes secondary data, then he has to look into various sources from where he can obtain them. In this case, he is certainly not confronted with the problems that are usually associated with the collection of original data. Secondary data may either be published data or unpublished data. Usually published data are available in a. Various publications of the central, state or local governments, b. Various publications of foreign governments or international bodies and their subsidiary organizations, StatFace, c. Technical and trade journal, d. Books, magazines and newspapers, c. Reports and publications of various associations connected with business and industry, banks, stock exchanges, etc. StatFace, f. Reports prepared by research scholars, universities, economists, etc., in different fields. And g. Public records and statistics, historical documents, and other sources of published information. Nowadays, data republished on the websites also. For example, the official website of Reserve Bank of India, National Stock Exchange, etc. Most of the data freely available and provided in Excel worksheets. The sources of unpublished data are many. They may be found in diaries, letters, unpublished biographics, and also may be available with scholar and research workers, trade associations, labor bureaus, and other public-private individuals and organizations. Researcher must be very careful in using secondary data. He must make a minute scrutiny because it is just possible that the secondary data may be unsuitable or may be inadequate in the context of the problem which the researcher wants to study. In this connection, Dr. A. L. Bully very aptly observes that it is never safe to take published statistic at their face value without knowing their meaning and limitations, and it always is necessary to criticize arguments that can be based on by way of caution. The researcher before using secondary data must see that they possess following characteristics. 1. Reliability of data. The reliability can be tested by finding out such things about the data. A. Who collected the data? B. What were the sources of data? C. Were they collected by using proper methods? D. At what were they collected? E. Was there any bias of the compiler? 7. F. What level of accuracy was desired? G. Was it achieved? 2. Suitability of data. The data that are suitable for one inquiry. Hence, if the available data are found to be unsuitable, they should not be used by the researcher. In this context, the researcher must very carefully scrutinize the definition of various term and units of collection used at the time of collecting the data from the primary source, originally. 3. Similarly, the object, scope and nature of the original inquiry must also be studied. If this researcher finds differences in these, the data will remain unsuitable for the present inquiry and should not be used. 4. Adequacy of data. If the level of accuracy achieved in data is found inadequate for the purpose of the present inquiry, they will be considered as inadequate and should not be used by the researcher. The data will also be considered as inadequate if they are related to an area which may be either narrower or wider than the area of the present inquiry. From all this we can say that it is very risky to use the already available data. The already available data should be used by the researcher only when he finds them reliable, suitable, and adequate. From all this we can say that it is very risky to use the already available data. The already available data should be used by the researcher only when he finds them reliable, suitable, and adequate. But he should not blindly discard the use of such data if they are readily available from authentic sources and are also suitable and adequate, for in that case it will not be economical to spend time and energy in field surveys for collecting information. At times, there may be wealth of usable information in the already available data which must be used by an intelligent researcher but with due precaution. Selection of appropriate method for data collection. Thus, there are various methods of data collection. As such, the researcher must judiciously select the methods for his own study, keeping in view the following factors. 1. Nature, scope and object of inquiry. This constitutes the most important factor affecting the choice of particular method selected should be such that it suit the type of inquiry that is to be conducted by the researcher. This factor is also important in deciding whether the data already available, secondary data, are to be used or the data not yet available, primary data, are to be collected. 2. Availability of funds. Availability of funds for the research project determines to a large extent the method to be used for the collection of data. When funds at the disposal of the researcher are very limited, he will have to select a comparatively cheaper method. Finance, in fact, is a big constraint in practice and the researcher has to act within this limitation. 3. Time factor. Availability of time also is to be taken into account in deciding a particular method of data collection. Some methods take relatively more time, whereas with others the data can be collected in a comparatively shorter duration. The time at the disposal of the researcher, thus, affects the selection of the method by which the data are to be collected. 4. Precision required. Precision required is yet another important factor to be considered at the time of selecting the method of collecting of data. But one must always remember that each method of data collection has ITD uses and none is superior in all situations. For instance, telephone interview method may be considered appropriate, assuming telephone population. If funds are restricted, time is also restricted and the data is to be collected in respect of few terms with or without a certain degree of precision. In case funds permit and more information is desired, personal interview method may be said to be relatively better. In case time is ample, funds are limited and much information is to be gathered with no precision, then mail questionnaire method can be regarded more reasonable. When funds are ample, time is also ample and much information with no precision is to be collected, then either personal interview or the mail questionnaire or the joint use of these two methods may be taken as an appropriate method of collecting data. Where a wide geographic area is to be covered, the use of mail questionnaire supplemented by personal interview will yield more reliable results per rupee spent than either method alone. The secondary data may be used in case the researcher finds reliable, adequate and appropriate for his research. While studying motivating influence in market researches or studying people's attitudes in psychological, social surveys, we can resort to the use of one or more of the projective techniques stated earlier. Such techniques are of immense value in case of attitude and the respondent is not aware of it. But when the respondent knows the reason and can tell the same if asked, then a non-projective questionnaire, using direct questions, may yield satisfactory results even in case of attitude surveys. Since projective techniques are as yet in an early stage of development and with the validity of the many of them remaining in open questions, it is usually considered better to rely on the straightforward statistical methods with only supplementary use of projective techniques. Nevertheless, in pretesting and in searching for hypotheses they can be highly valuable. Thus, the most desirable approach with regard to the selection of the method depends on the nature of the particular problem and on the time and resources, money and personnel available along with the desired degree of accuracy. But, over and above all this much depends upon the ability and experience of the researcher. Dr. A. L. Bowley's remark in this context is very appropriate when he says that in collection of statistical data common sense is the chief requisite and experience the chief teacher. Case study method. The case study method is a very popular form of qualitative analysis and is considered nowadays a common tool of data collection. It involves a careful and complete observation of a social unit, be that unit a person, a family, an institution, a cultural group, or even the entire community. It is a method of study in depth rather than breadth. The case study deal with the process that take place in their interrelationship. Thus, case study is essentially an intensive investigation of the particular unit under consideration. The object of the case study method is to locate the factors that account for the behavior patterns of the given unit as an integrated totality. Review questions. 1. What is meant by data collection? 2. State the role of data collection in research. 3. Classify data collection techniques. 4. What is primary data? 5. What is secondary data? 6. Differentiate between primary data and secondary data. 7. What are the sources of secondary data? 8. What is meant by observation method? 9. What is interview method of data collection? 10. What is personal interview? 11. What are different types of structured interviews? 12. Explain telephone interview. 13. What are the precautions to be taken before interview? 14. What is meant by questionnaire? 15. What are essentials of a good questionnaire? 16. What is meant by schedule? 17. Differentiate between questionnaire and schedule. 18. What are projective techniques? 19. Explain some of the projective techniques. Unit 15. MASUREMENT and data introduction. All types of research require data. So, the basic problem of any research is to find facts and figures relating to particular phenomenon under study. The success of research depends on the availability and deployment of data. In this world, data is continuously generated in large volume, whether for ResCarc or recording. When we say that Messi wears jersey number 10, or Neymar is number 1 among Brazilian strikers with 48 goals, or Coricode is 40 kilometers away for area code, or the monthly average expenditure of a student on mobile recharge is 150 rupees, really we are generating data. The process of generating data, by assigning numbers or figures led to the idea of measuring it. Measurement is a general term referring to the process of giving numbers to concepts and phenomena. After measuring, we have to place the measured object at appropriate scales, so as to enable further manipulation. This process, which is more specific, is called scaling. Measurement is simple and takes only 4 forms, whereas scaling is more complex and takes a number of forms, some of which are even overlapping. This unit deals with the aspect of measurement, and the next unit is devoted to discuss scaling process. Process of measurement. In our daily life we are said to measure when we use some yardstick to determine weight, height or some other features of a physical object. We also measure when we judge how well we like song, a painting or personalities of our friends. We thus measure physical objects as well as abstract concepts. Measurement is a relatively complex and demanding task, especially so when it concerns qualitative or abstract phenomena. Other examples of qualitative characteristic are taste, honesty, intelligence, consumers' perception and brand loyalty, etc. These characteristics are also called as constructs. The feeling and perception of customers and employees are very important for a company. It is easy to assign number in respect of properties of some objects, but it is relatively difficult in respect of others. For instance, measuring such things as social conformity, intelligence or marital adjustment is much less obvious and requires much closer attention than measuring physical weight, biological age or person's financial assets. In other words, properties like weight, height, etc. can be measured directly with some standard unit of measurement, but it is not that easy to measure properties like motivation to succeed, ability to stand stress and the like. For the meaningful assessment of the qualitative characteristic, it is essential that they are also measured. Quantitative and qualitative data. Measurement is defined as a process of associating numbers or symbols to observation obtained in a ResCarc study. These observations could be qualitative or quantitative. Most of the analysis can be conducted using data. For example, mean, standard deviation, etc. can be computed for quantitative characteristic. Qualitative can be counted and cannot be computed. Therefore, the researcher must have a clear understanding of the type of characteristic or variable before collecting the data. The observation on qualitative variables may also be assigned numbers. For example, we can record a person's marital status as 1, 2, 3 or 4 depending on whether the person is single, married, widowed or divorced. We can as well record yes or no answers to a question as 0 inches and 1, or as 1 and 2 OC perhaps as 59 and 60. In this artificial or nominal way, categorical data, qualitative or descriptive, can be made into numerical data, and if we thus code the Venus categories, we refer to the numbers we recorded as nominal data. Nominal data is numerical in name only because they do not share any of the properties of the numbers we deal in ordinary arithmetic. For instance, if we record marital status as 1, 2, 3 or 4 as stated above, we cannot write 4 greater than 2 or 2 less than, and we cannot write 3 minus 1 equals 4 to 2.1 plus 3 equals 4 or 4 halves equals 2. In those situations when we cannot do anything except set up inequalities, we refer to the data as ordinal data. For instance, if one mineral can Sriracha another, it receives a higher hardness number, and on Mohs scale the numbers from 1 to 10 are assigned respectively to tale, gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, sapphire and diamond. With these, number can write 5 greater than 2 or 6 less than 9 as apatite is harder than gypsum and feldspar is softer than sapphire, but we cannot write for example 10 minus 9 equals 5.4, because the difference in hardness between diamond and sapphire is actually much greater than that between apatite and fluorite. It would also be meaningless to say that topaz is twice as hard as fluorite simply because the respective hardness numbers on Mohs scale are 8 and 4. The greater than symbol, i.e., greater than, in connection with ordinal data may be used to designate happier than, preferred to, and so on. When in addition to setting up inequalities we can also form differences, we refer to the data as interval data. Suppose we are given the following temperature readings in degrees Fahrenheit: 58, 63, 70, 95,110,126 and 135. In this case, we can write 100 greater than 70 or 95 less than 135, which simply means that 110 is warmer than 70 and that 95 is cooler than 135. We can also write for example means that 110 is warmer than 70 and that 95 is cooler than 135. We can also write for example 9570, 135, 110. Suppose we are given the following temperature readings in degrees Fahrenheit: 58, 63, 70, 95,110,126 and 135. In this case, we can write 100 greater than 70 or 95 less than 135, which simply means that 110 is warmer than 70 and that 95 is cooler than 135. We can also write for example means that 110 is warmer than 70 and that 95 is cooler than 135. We can also write for example 9570, 135, 110, since equal temperature differences are equal in the sense that the same amount of heat is required to raise the temperature of an object from 70 to 95 or from 110 to 135. Suppose we are given the following temperature readings in degrees Fahrenheit: 58, 63, 70, 95,110,126 and 135. In this case, we can write 100 greater than 70 or 95 less than 135, which simply means that 110 is warmer than 70 and that 95 is cooler than 135. We can also write for example means that 110 is warmer than 70 and that 95 is cooler than 135. We can also write for example 95701351110, since equal temperature differences are equal in the sense that the same amount of heat is required to raise the temperature of an object from 70 to 95 or from 110 to 135. On the other hand, it would not mean much if we said that 126 is twice as hot as 63, even though 126/63 equals 2. To show the reason, we have only to change to the centigrade scale, where the first temperature become 5/9, 126 to 32 equals 52. The second temperature becomes 5/9, 63 to 32 equals 17, and the first figure is now more than 3 times the second. The difficulty arises from the fact that Fahrenheit and centigrade scales both have artificial origins, zeros, i.e., the number 0 of neither scale is indicative of the absence of whatever quantity we are trying to measure. When in addition to setting up inequalities and forming differences, we can also form quotients, i.e., when we can perform all the customary operations of mathematics. We are referred to such data as ratio data. In this sense, ratio data includes all the usual measurement or determinations of length, height, money amounts, weight, volume, area, pressures, etc. The above stated distinction between nominal, ordinal, interval, and ratio data is important for the nature of a set of data may suggest the use of particular statistical techniques. A researcher has to be quite alert about this aspect while measuring properties of objects or of abstract concepts. Concepts, indicators, and variables. In the process of formulating a research problem, there are two important considerations: use of concepts and measurement of properties. Concepts are highly subjective, as their understanding varies from person to person and therefore may not be measurable. In a research study, it is important that the concepts used should be operationalized in measurable terms so that the extent of variation in respondents' understanding is reduced, if not eliminated. Techniques to tackle issues like how to operationalize concepts, how to identify variables and indicators play an important role in reducing this variability. Concepts. Concepts are basic elements of scientific method. Concepts emerge from phenomenon. Concepts are more abstract than phenomena. According to Good and Hatt, a concept is as like a fact and is an abstraction, not phenomena, and it takes its meanings from the thought framework within which it is placed. Concepts are the foundation of all human communication and thought, besides being basic to scientific method. Certain concepts are difficult to define, especially when human behavior and attitude are involved. Weight, height, energy are easy to define. They can be pointed out and pictures can be taken of them. However, it is difficult to define certain concepts like frustration, happiness, motivation, aggression, etc. Because they are constructs. They exist in our mental framework only. They cannot be touched or seen but can only be felt. They can be called constructs. Constructs represent inferences at a higher level of abstractions from concrete events, and their meanings cannot be easily conveyed by pointing to specific objects, individuals, or events. Concept and operationalization. If you are using a concept in your study, you need to consider its operationalization, that is, how it will be measured. In most cases, to operationalize a concept, you first need to go through the process of identifying indicators, a set of criteria which reflect the concept, which can then be converted into variables. Most of the concepts can easily be converted into indicators and then variables. For example, we may want to decide if a person is rich or not. Richness is the concept, and one first needs to decide upon the indicators of richness. Monthly income is one such indicator, and it takes the shape of a variable which can be measured. Indicators. Each concept has certain indicators. Indicators are characteristics by which concepts can be operationalized and measured. For example, the term asset is a concept. Indicators of this concept are house, car, and other investments. Converting the value of each one will give total value of the assets owned by a person. Similarly, the indicators of effectiveness of a health program are patients, change in mortality, change in birth rates, etc. There are appropriate variables to measure these indicators. The choice of indicators for a concept might vary with the researcher, but those selected must have a logical link with the concept. Variables. An image, perception, or concept that is capable of measurement is called a variable. A variable is capable of taking on different values. In other words, a concept that can be measured is called a variable. According to Kurlinger, a variable is a property that takes on different values. Putting it redundantly, a variable is some that varies. A variable is a symbol of which numerals or values are attached. Black and Champion define a variable as rational units of analysis that can assume any one of a number of designated sets of values. A concept that can be measured on any one of the 4 types of measurement scale, which have varying degree of precision in measurement, is called a variable. There are some who believe that scientific methods are incapable of measuring feelings, preferences, values, and sentiments. In our view, most of such attitudes can be measured, though indirectly. These feelings and judgments are based upon observable behavior in real life, though the extent to which the behavior reflect their judgments may vary from person to person. Types of variables. Number 7a. Variables are numerous types. They can be classified on 3 criteria: causal relation, design of the study, and unit of measurement. Number 7a. In studies that attempt to investigate a causal relation, 3 sets of variables may operate. Number 7a. Change variable, which are responsible for bringing about change in a phenomenon. They are also called independent variable. Number 7a. Outcome variable, affect cause and effect relationship, but are not considered or measured for the time being. Number 7a. From the viewpoint of the study design, variables may be active variable and attribute variable. Active variable is that variable that can be manipulated or changed or controlled. Number 7a. Attribute variable is that variable that cannot be manipulated, changed, or controlled, and that reflect the characteristics of the study population. For example, age, gender, education, and income. Number 7a. From the viewpoint of unit of measurement, variables may be categorical variables, constant variable, continuous variables, etc. Number 7a. Categorical variables are measured on nominal or ordinal measurement scales. For example, rich, poor, good, bad, etc. Number 7a. Constant variables are those which have only one value or category. For example, taxi, water, etc. Continuous variables have continuity in their measurement. For example, age, income, attitude, etc. Classifications of measurement scales. From what has been stated above, we can write that scales of measurement can be considered in terms of their mathematical properties. The most widely used classification of measurement scales are A. Nominal scale, B. Ordinal scale, C. Interval scale, and D. Ratio scale. Nominal scale. Normal scale is simply a system of assigning MMBER symbols to events in order to label them. The usual example of the assignment of numbers of basketball players in order to identify them. Such numbers cannot be associated with an ordered scale, for their order is of no consequence. The numbers are just convenient labels for the particular class of events and as such have no quantitative value. Nominal scales provide convenient ways of keeping track of people, objects, and events. One cannot do much with the numbers involved. For example, one cannot usefully average the numbers on the back of a group of football players and come up with a meaningful value. Neither can one usefully compare the numbers assigned to one group with the numbers assigned to another. The counting of members in each group is the only possible arithmetic operation when a nominal scale is employed. Accordingly, we are restricted to use mode as the measure of central tendency. There is no generally used measures of dispersion for nominal scales. Chi-square test is the most common test of statistical significance that can be utilized, and for the measures of correlation, the contingency coefficient can be worked out. Nominal scale is the least powerful level of measurement. E indicates no order-distance relationship and has no arithmetic origin. A nominal scale simply describes differences between things by assigning them categories. Nominal data is, thus, counted data. The scale wastes any information that we may have about varying degrees of attitude, skills, understanding, etc. In spite of all this, nominal are still very useful and are widely used in surveys and other sex post facto research when data are classified by major subgroups of the population. Ordinal scale. The lowest level of the ordered scale that is commonly used is the ordinal scale. The ordinal scale places events in order, but there is no attempt to make the intervals of the scale equal in terms of some rule. Rank orders represent ordinal scales and are frequently used in RESPARC relating to qualitative phenomena. A student's rank in his graduation class involves the use of an ordinal scale. One has to be very careful in making statement about scores based on ordinal scale. For instance, if Ram's position in his class is 10 and Mohan's position is 40, it cannot be said that Ram's position is 4 times as good as that of Mohan. The statement would make no sense at all. Ordinal scale only permit the ranking of room items from highest to lowest. Ordinal measures have no absolute values and the real differences between adjacent ranks may not be equal. All that can be said is, person sits higher or lower on the scale than another, but more precise comparisons cannot be made. Thus, the use of an ordinal scale implies a statement or greater than, or less than. An equality statement is also acceptable without our being able to state how much greater or less. The real differences between ranks 1 and the second of may be more or less than the differences between ranks 5 and 6. Since the numbers of the scale have only a rank meaning, the appropriate measure of central tendency is the median. A percentile or quartile measure is used for measuring dispersion. Correlations are restricted to various rank order methods. Measure of statistical significance are restricted to the non-parametric methods. Interval scale. In the case of interacy scale, the intervals are adjusted in terms of some rule that have been established as a basis for making the units equal. The units are equal only insofar as one accepts the assumption on which the rule is based. Interval scales can have an arbitrary zero, but it is not possible to determine for them what may be called an absolute zero or the unique origin. The primary limitation of the interval scale is the lack of a true zero. It does not have the capacity to measure the complete absence of a trait or characteristic. The Fahrenheit scale is an example of an interval scale and shows similarities in what one can and can do with it. One can say that an increase in temperature from 30 to 40 involves the same. The increase in temperature is an increase from 60 to 70, but one cannot say that the temperature of 60 is twice as warm as the temperature of 30 because both numbers are dependent on the fact that the zero on the scale is set arbitrarily at the temperatures 30 and 60 means nothing because zero is an arbitrary point. Interval scales provide more powerful measurement than ordinal scales, for interval scale also incorporates the concept of equality of interval. As such, more powerful statistical measures can be used with interval scales. Mean and the appropriate measure of central tendency. While standard deviation is the most widely used measure of dispersion, product moment correlation techniques are appropriate in the generally used tests for statistical significations of the T test and F test. Ratio scale. Ratio scales have an absolute or true zero of measurement. The term absolute zero is not as precise as it was once believed to be. We can conceive of an absolute zero of length and similarly we can conceive of an absolute zero of time. For example, the 0 point on a centimeter scale indicates the complete absence of length or height. But an absolute zero of temperature is theoretically unobtainable and it remains a concept existing only in the scientist's mind. The number of minor traffic rule violations and the number of incorrect letters in a page of TypeScript represent scores on ratio scales. Both these scales have absolute zeros and as such all minor traffic violations and all typing errors can be assumed to be equal in significance. With ratio scales involved one can make statements like, Jody's typing performance was twice as good as that of Ritu. The ratio involved does have significance and facilitates a kind of comparison which is not possible in case of an interval scale. Ratio scale represents the actual amount of variables. Measures of physical dimensions such as weight, distance, etc. are examples. Generally all statistical techniques are usable with ratio scales and all manipulations that one can carry out with real numbers can also be carried out with ratio scale values. Multiplication and division can be used with this scale but not with other scales mentioned above. Geometric and harmonic means can be used as measures of central tendency and coefficients of variation may also be calculated. Thus, proceeding from the nominal scale, the least precise type of scale, to ratio scale, the most precise relevant information is obtained increasingly. If the nature of the variables permits, the researcher in physical science have the advantage to describe variables in ratio scale from, but the behavioral sciences are generally limited to describe variables in interval scale from, a less precise type of measurement. Goodness of measurement scales. A measurement scale has to have certain desirable qualities to judge goodness in measuring the characteristic under study. These qualities are described below. I. Validity. Validity is the most critical criterion and indicates the degree to which an instrument measures what it is supposed to measure. Validity can also be though of its utility. In other words, validity is the extent to which differences found with a measuring instrument reflect true differences among those being tested. But the question arises, how can one determine validity without direct confirming knowledge? The answer may be that we seek other relevant evidence that confirms the answers we have found with our measuring tool. What is relevant evidence often depends upon the nature of the research problem and the judgment of the researcher. But one can certainly consider three types of validity in this connection: I. Content validity, criterion-related validity, and E. Construct validity. I. Content validity is the extent to which a measuring instrument provides adequate coverage of the topic under study. If the instrument contains a representative sample of the universe, the content validity is good. Its determination is primarily judgmental and intuitive. It can also be determined by using a panel of persons who shall judge how well the measuring instrument meets the standards, but there is no numerical way to express it. E. Criterion-related validity relates to our ability to predict some outcome or estimate the existence of some current condition. This form of validity reflects the success of measures used for some empirical estimating purpose. The concerned criterion must possess the following qualities. 1. Relevance. A criterion is relevant if it is defined in terms we judge to be the proper measure. 2. Freedom from bias. Freedom from bias is attained when the criterion gives each subject an equal opportunity to score well. 3. Reliability. A reliable criterion is stable or reproducible. 4. Availability. The information specified by the criterion must be available. In fact, a criterion-related validity is a broad term that actually refers to I. Predictive validity and E. Concurrent validity. The former refers to the usefulness of a test in predicting some future performance, whereas the latter refers to usefulness of a test in closely relating to other measures of known validity. Criterion-related validity is expressed as the inefficient of correlation between test scores and some measure of future performance or between test scores and scores on another measure of known validity. Construct validity is the most complex and abstract. A measure is said to possess construct validity to the degree that it confirms the predicted correlations with other theoretical propositions. Construct validity is the degree to which scores on a test can be accounted for by them explanatory constructs of a sound theory. For determining construct validity, we associate a set of other proposition with the results received from using out measurement instrument. If measurements on our devised scale correlate in a predicted way with these other propositions, we can conclude that there is some construct validity. If the above stated criteria and tests are met with, we may state that our measuring instrument is valid and will result in correct measurement, otherwise we shall have to look for more information and or resort exercise of judgment. Reliability. The test of reliability is another important test of sound measurement. A measuring instrument is reliable if it provides consistent results. Reliable measuring instrument does contribute to validity, but a reliable instrument need not be a valid instrument. For instance, a scale that consistently overweighs objects by 5 kgs is a reliable scale, but it does not give a valid measure of weight. But the other way is not true, i.e., a valid instrument is always reliable. Accordingly, reliability is not as valuable as validity, but it is easier to assess reliability in comparison to validity. If the quality of reliability is satisfied by an instrument, then while using it we can be confident that the transient and situational factors are not interfering. Two aspects of reliability, viz., stability and equivalence, deserve special mention. The stability aspect is concerned with securing consistent results with repeated measurements of the same person and with the same instrument. We usually determine the degree of stability by comparing the results of repeated measurements. The equivalence aspect considers how much error may get introduced by different investigators or different samples of the items being studied. A good way to test for the equivalence of measurements by two investigators is to compare their observations of the same events. Reliability can be improved in the following two ways. By understanding the conditions under which the measurements take place, i.e., we must ensure that external sources of variation such as boredom, peg, etc. are minimized to the extent possible. That will improve stability aspect. By carefully designed directions for measurement with no variations from group to group, by using trained and motivated persons to conduct the research and also by broadening the sample of items used. This will improve equivalence aspect. Practicality. The practicality characteristic of a measuring instrument can be judged in terms of economy, convenience and interpretability. From the operational point of view, the measuring instrument ought to be practical, i.e., it should be economical, convenient and interpretable. Economy consideration suggests that some trade-off is needed between the ideal research project and that which the budget can afford. The length measuring instrument is an important area where economic pressures are quickly left. Although more items of greater reliability as stated earlier, but in the interest of limiting the interview or observation time, we have to take only few items for our study purpose. Similarly, data collection methods to be used are also dependent at times UOP and economic factors. Convenience test suggests that the measuring instrument should be easy to administer. For this purpose one should give due attention to the proper layout of the measuring instrument. For instance, a questionnaire, with clear instruction illustrated by examples, is certainly more effective and easier to complete than one which lacks these features. Interpretability consideration is especially important when persons other than the designers of the test are to interpret the results. The measuring instrument, in order to be interpretable, must be supplemented by 3 detailed instructions for administering the test, b. scoring keys, c. evidence about the reliability and guides for using the test and interpreting results. Accuracy. The characteristic of accuracy of a measurement scale means it should be a true representative of the observation of underlying characteristic. For example, measuring with an inch, scale will provide accurate value only up to 1/8 of an inch, while measuring with cm, scale will provide more accurate value. Sources of error in measurement. Measurement should be precise and unambiguous as an ideal research study. This objective, however, is often not met with an entirety. As such, the researcher must be aware about the sources of error in measurement. The following are the possible sources of error in measurement. Respondent. At times the respondent may be reluctant to express strong negative feelings, or it is just possible that he may very little knowledge but may not admit his ignorance. All this reluctance is likely to result in an interview of guesses. Transient factors like fatigue, boredom, anxiety, etc. may limit the ability of the respondent accurately and fully. Situation. Situational factors may also come in the way of correct measurement. Any condition which places a strain on interview can have Strauss effects on the interviewer-respondent rapport. For instance, if someone else is present, he can distort responses by joining in or merely by being present. If the respondent feels that anonymity is not assured, he may be reluctant to express certain feelings. Measurer. The interviewer can distort responses by rewording or reordering questions. His behavior, style and looks may encourage or discourage certain replies from respondents. Careless mechanical processing may distort the findings. Errors may also creep in because of incorrect coding, faulty tabulation and or statistical calculations, particularly in the data analysis stage. Instrument. Error may arise because of the defective measuring instrument. The use of complex words, beyond the comprehension of the respondent, ambiguous meanings, poor printing, inadequate space for replies, response choice omissions, etc. are a few things that make the measuring instrument defective and may result in measurement errors. Another type of instrument deficiency is the poor sampling of the universe of items of concern. Researcher must know that correct measurement depends on successfully meeting all of the problems listed above. He must, to the extent possible, try to eliminate, neutralize or otherwise deal with all the possible sources of error so that the final results may not be contaminated. Techniques of developing measurement tools. The technique of developing measurement tools involves a 4-stage process, consisting of concept development, specification of concept dimensions, selection of indicators, and formulation of index. Concept development. The first and foremost step is that of concept development, which means that the researcher should arrive at an understanding of the major concepts pertaining to his study. This step developmental concepts are often already established. Specification of concept dimensions. The second step requires the researcher to specify the dimensions of the concepts that they developed in the first stage. This task may either be accomplished by deduction, i.e., by adopting a more or less intuitive approach, or by empirical correlation of the individual dimensions with the total concept and or the other concepts. For instance, one may think of several dimensions such as product reputation, customer treatment, corporate leadership, concern for individuals, sense of social responsibility and so forth when one is thinking about the image of certain company. Selection of indicators. Once the dimensions of a concept have been specified, the researcher must develop indicators for measuring each concept element. Indicators are specified questions, scales, or other devices by which respondents' knowledge, opinion, expectation, etc. are measured. As there is seldom a perfect measure of a concept, the researcher should consider several alternatives for the purpose. The use of more than one indicator gives stability to the scores and it also improves their validity. Formulation of index. The last step is that of combining the various indicators into an index, i.e., formation of an index. When we have several dimensions of a concept or different measurements of a dimension, we may need to combine them into a single index. One simple way for getting an overall index is to provide scale values to the responses and then sum up the corresponding scores. Such an overall index would provide a better measurement tool than a single indicator because of the fact that an individual indicator has only a probability relation to what we really want to know. This way we must obtain an overall index for the various concepts concerning the research study. Review questions. 1. What is the role of data in research? 2. What is meant by measurement? 3. How data can be generated. 4. State the necessity of measurement. 5. Define measurement. 6. What are concepts? 7. Define indicator. 8. How does concept differ from indicator? 9. What are variables? 10. Explain operationalization of concept. 11. Give a classification of variable. 12. What are the different types of measurement scales? 13. Explain nominal scale. 14. What is a ordinal scale? 15. Compare interval scale with ratio scale. 16. What are the desirable qualities of a scale? What are the sources of error in measurement? 17. Explain the concept of development measurement tool. Unit 16 Scaling. Introduction. In research we quite face measurement problem, since we want a valid measurement but may not obtain it, especially when the concepts to be measured are complex and abstract and we do not possess a standardized measurement tools. Alternatively, we can say that while measuring attitudes and opinions, we face the problem of their valid measurement. Similar problem may be faced by a researcher, of course, in a lesser degree, while measuring physical or attitudinal concepts. As such we should study some procedures which may enable us to measure and determine abstract concepts more accurately. This brings us to the study of sealing techniques. Measurement describes the procedures of assigning numbers to various degrees of opinion, attitude and other concepts. This can be done in two ways, viz. I. Making a judgment about some characteristic of an individual and then placing him directly on a scale that has been defined in terms of that characteristic, and E. Constructing questionnaire in such a way that the score of individual's responses assigns him a place on a measurement scale. Scaling is an extension of the concept of measurement. It can also be said that the result of measurement is scaling. Scaling refers to the process of placing a measured object, characteristic or attitude on the appropriate point on a scale. Scaling is ascertaining the score of characteristics, using measurement, on a continuum, subject to rules. The difference between measurement and scaling is that measurement is the assignment of numbers to objects or respondents and sealing is the process of placing them on a continuum with respect to the number scored by them. Alter L. Edwards has defined scaling as referring to measurement. In his words, scaling is a proctor for assignment of numbers or other symbols to a property of objects in order to impart some of the characteristics of numbers to the properties in question. Hence the term scaling is applied to the procedures for attempting to determine quantitative measures of subjective and abstract concepts. Scale. It may be stated here that a scale is a continuum, consisting of the highest point, in terms of some characteristic e.g., preference, favorableness, etc., and the lowest point along with several intermediate points between these two extreme points. These scale point positions are so related to each other that when the first point happens to be the highest point, the second point indicates a higher degree in terms of a given characteristic as compared to the third points, and the third point indicates a higher degree as compared to the fourth, and so on. Numbers for meaning the distinction of degree in the attitudes, opinion are thus assigned to individuals corresponding to their scale positions. Scales may take physical form or hypothetical form. Determination of scale. Scales appropriate for measuring a phenomenon or attitude can be determined and classified on the basis of following 6 factors. Number 7a, objective of study. Number 7a, nature of response. Number 7a, degree of subjectivity involved. Number 7a, number of dimensions against which responses are noted. Number 7a, scale properties. Number 7a, scale construction technique. Essential of scaling. Number 7a, continuum. If in a social phenomenon, the various factors are logically related and are in the form of a continued measurement, they can be called scalable or measurable. If they are stray facts, lying here and there, it would not be possible to measure them. They are logically unrelated and so they cannot be included in the same scale. Investigators should have full knowledge of the universe from which samples have been drawn and also of the subject under study. Then only scaling becomes appropriate and accurate. Continuum means judging the scalability of the phenomenon under study. Number 7a, reliability. The scale under for measuring the social phenomenon must be reliable. Reliability means that it should consistently produce the same result when applied to the same design. That is, reliability implies uniformity. Number 7a, validity. A scale is called valid if it measures correctly what is expected to measure. Validity implies correct measurement. Number 7a, weighting items. The scale becomes more valid if proper weights are given to various points included in the scale. The attributes involved in a study are not of equal importance and so they are to be provided with proper weights. Number 7a, equality of units. Construction of the scale involves ordering or ranking of units of a continuum. If the units are unequal, the construction of scale becomes difficult. Equality of units is a desirable characteristic but not essential for sound scientific procedure. In order to make the units equal, sometimes subtraction or addition can be made. Difficulties in scaling. Number 7a, complexity of social phenomena. Social phenomena are a very complex affair. It is not easy to find them quantitatively. Because of this complexity, it is not easy to draw scales for measuring them. Number 7a, change in human behavior. Different types of changes are taking place in the circumstance of everyone's life. Number 7a, change in human behavior. Different types of changes are taking place in the circumstance of everyone's life. So people have to adjust their life to suit these changes. Therefore they have to change their behavior pattern. Because of these changes in human behavior of social phenomena also face problems. Number 7a, heterogeneity in the nature of human beings. People belong to groups of different culture and different social customs. Therefore it is difficult to have a common scale applicable to all people. No universally accepted scale can be formulated for measuring the human behavior pattern. Because of these changes in human behavior of social groups. Number 7a, qualitative nature of a social phenomena. Social phenomena are qualitative in nature. Qualitative characters cannot be measured, so they are to be converted to quantitative data, which is not easy task. Sources of errors in scaling. The various sources of errors in measurement are. Number 7a, response error. Sometimes the respondent may be reluctant to express strong negative feelings. Sometimes the respondent may have very little knowledge about the various aspects but he will not admit this ignorance. The figure, boredom, anxiety etc. of the respondent may limit the ability of the respondent to express his response accurately. In these situations the researcher has to make guesses in interviews. These guesses may sometimes be erroneous, thus resulting into wrong measurement. Number 7a. Situational errors. Situational factors also cause error in measurement. If something happens at the time of interview which places strain on interview, that will have serious effects on the response from respondent. For example, if somebody is present at the time of interview, the respondent may not reveal facts correctly. Number 7a. Errors due to faulty instrument. Errors may occur due to defective measuring instrument. Use of complex words, ambiguous meanings, poor printing, inadequate space for replies, etc. may result in measurement errors. Scale classification base. The number of procedures or the scaling procedures may be broadly classified on one or more of the following bases. A. Subject orientation. B. Response form. C. Degree of subjectivity. D. Scale properties. E. Number of dimension. And F. Scale construction techniques. We take up each of these separately. A. Subject orientation. Under it, a scale may be designed to measure characteristics of the respondent who completes it or to judge the stimulus object which is presented to the respondent. In respect of the former, we presume that the stimuli presented are sufficiently homogeneous so that the between stimuli variation is small as compared to the variation among respondents. In the latter approach, we ask the respondent to judge some specific object in terms of one or more dimension, and we presume that the between respondent variation will be small as compared to the variation among the different stimuli presented to respondents for judging. B. Response form. Under this we may classify the scales as categorical and comparative. Categorical scales are also known as rating scales. These scales are used when a respondent scores some object without direct reference to other objects. Under comparative scales, which are also known as ranking scales, the respondent is asked to compare two or more objects. In this sense, the respondent states that one object is superior to the other, or that three models of pen rank in order 1, 2, and 3. The essence of ranking is, in fact, a relative comparison of a certain property of two or more objects. C. Degree of subjectivity. With this basis, the scale data may be based on whether we measure objective personal preference or simply make non-references judgments. In the former case, the respondent is asked to choose which person he favors or which solution he would like to see employed, whereas in the latter case he is simply asked to judge which person is more effective in some aspect or which solution will take asked to judge which person is more effective in some aspect or which solution will take fewer resources without reflecting any personal preferences. D. Scale properties. Considering scale properties, one may classify the scale as nominal, ordinal, interval, and ratio scales. Nominal scales merely classify without indicating order, distance, or unique origin. Ordinal scales indicate magnitude relationships of more than, or less than, but indicate no distance or unique origin. Interval scales have both honor and distance values, but no unique origin. Ratio scales possess all these features. E. Number of dimensions. In respect of this basis, scales can be classified as unidimensional and multidimensional scales. Under the former we measure only one attribute of the respondent or object, whereas multidimensional scaling recognizes that an object might be described better by using the concept of an attribute space of n dimensions, rather than a single dimension continuum. Scale construction approaches. Following are the 5 main techniques by which scales can be developed. I. Arbitrary approach. It is an approach where scale is developed on ad hoc basis. This is the most widely used approach. It is presumed that such scales measure the concepts for which they have been designed, although there is little evidence to support such an assumption. E. Consensus approach. Here a panel of judges evaluate the items chosen for inclusion in the instrument in terms of whether they are relevant to the topic area and unambiguous in implication. E. Item analysis approach. Under it, a number of individuals' items are developed into a test which is given to a group of respondents. After administering the test, the total scores are calculated for every one. Individual items are then analyzed to determine which items discriminate between persons or objects with high total scores and those with low scores. IV. Cumulative scales. Chosen on the basis of their conforming to some ranking of items with ascending and descending discriminating power. For instance, in such a scale the endorsement of all items indicating a less extreme position is seen. V. Factor scales. May be constructed on the basis of intercorrelations of items which indicate that a common factor accounts for the relationship between items. This relationship is typically measured through factor analysis method. Non-comparative scaling techniques. Most common non-comparative scaling techniques are continuous rating or graphic rating. Itemized rating. Simple multiple category scale. Verbal frequency scale. These techniques are discussed in brief as follows. Continuous rating or graphic rating. The graphic rating scale is quite simple and is commonly used in practice. Under it, various points are usually put along the line to form a continuum, and the rater indicates his rating by simply making a mark, such as U, at the appropriate point on a line that runs from one extreme to the other. Scale points with brief descriptions may be indicated along the line, their function being to assist the rater in ascertain people's liking or disliking any product. This type of scale has several limitations. The respondents may check at almost any position along the line, which is fact may increase. D. Difficulty of analysis. The meaning of the terms like very much, and somewhat, may depend upon respondent's frame of reference so much so that the statement might be challenged in terms of its equivalency. Several other rating scale variants, e.g. boxes replacing line, may also be used. Itemized rating. A scale having number or brief descriptions of each category is provided. Categories are ordered in terms of scale positions. The respondents select one of the categories that best describes the stimulus object. Commonly used itemized rating scales are Likert scale, Thurstone scale, Goodman scale, semantic differential scale, single or multiple category scale, etc. Likert scale. Likert scales or summated scales are developed by utilizing the item analysis approach, wherein a particular item is evaluated on the basis of how well it discriminates between those persons whose total score is high and those whose score is low. Those items or statements that best meet this sort of discrimination test are included in the final instrument. Thus, summated scales consist of a number of statements which express either a favorable or unfavorable attitude towards the given object to which the respondent is asked to react. The respondent indicates his agreement or disagreement with each in the statement in the instrument. Each response is given a numerical score, indicating its favorableness towards an issue. Most frequently used summated scales in the study of social attitudes follow the pattern devised by Likert. For this reason they are often referred to as Likert-type scales. In a Likert scale, the respondent is asked to respond to each of the statement in terms of several degrees, usually live degrees, but at times 3 of the 7th may also be used, of agreement or disagreement. For example, when asked to express opinion whether one considers his job quite pleasant, the respondent may respond in any one of the following ways. I strongly agree, E undecided, I disagree, V strongly disagree. We find that these 5 points constitute the scale. At one extreme of the scale there is strong agreement with the given statement, and at the other, strong disagreement, and between them lie intermediate points. We may illustrate this as under. Each point on the scale gains a score. Response indicating the least favorable degree of job satisfaction is given the least score, say 1, and the most favorable is given the highest score, say 5. These score values are normally not printed on the instrument but are shown here just to indicate the scoring pattern. The Likert scaling technique, thus, assigns a scale value to each of the 5 responses. The same thing is done in respect of each and every statement in the instrument. This way the instrument yields a total score for each respondent, which would then measure the respondent's favorableness towards the given point of view. If the instrument consists of, say 30 statements, the following score values would be revealing. 30x5 equals 150 most. Response possible. 30x3 equals 90 a neutral attitude. 30x1 equals 30 most unfavorable attitude. The scores for any individual would fall between 30 and 150. If the score happens to be above 90, it shows favorable opinion to the given point of view. A score of below 90 would mean unfavorable opinion, and a score of exactly 90 would be suggestive of a neutral attitude. Procedures. The procedure for developing a Likert type is as follows. I. As a first step, the researcher collects a large number of statements, expresses definite favorableness or unfavorable in statements is approximately equal. E. After the statement have been gathered, a trial test should be administered to a number of subjects. In other words, a small group of people, from those who are going to be studied finally, are asked to indicate their response to each statement by checking one of the categories of agreement or disagreement using 5-point scale as stated above. E. The response to various statements are scored in such a way that a response indicative of the most favorable attitude is given the highest score of 5 and that with the most unfavorable attitude is given the lowest score, say of 1. IV. The next step is to array these total scores and find out those statements which have a high discriminatory power. For this purpose, the researcher may select some part of the highest and the lowest total scores. Say the top 25% and the bottom 25%. These two extreme groups are interpreted to represent the most favorable and the least favorable attitudes and are used as circa groups by which to evaluate individual statements. This way we determine which statements consistently correlate with low favorability and which with high favorability. B. Only those statements that correlate with the total test should be retained in the final instrument and all others must be discarded from it. Advantages. The Likert type scale has several advantages. Mention may be made of the important ones. A. It is relatively easy to construct the Likert type scale in comparison to Thurstone type scale can be performed without a panel of judges. B. Likert type scale is considered more reliable because under it respondent answer each statement included in the instrument. As such it also provides more information and data than does the Thurstone type scale. C. Each statement, included to the Likert type scale is given an empirical test for discriminating ability and such unlike Thurstone type scale, the Likert type scale permits the use of statements that are not manifestly related to have a direct relationship to the attitude being studied. D. Likert type scale can easily be used in respondent-centered and stimulus-centered studies, i.e., through it we can study how responses differ between stimuli. E. Likert type scale takes much less time to construct. It is frequently used by the students of opinion research. Moreover, it has been reported in various research studies that there is high degree of correlation between Likert type scale and Thurstone type scale. Limitations. There are several limitations of the Likert type scale as well. One important limitation is that, with this scale, we can simply examine whether respondents are more or less favorable to a topic, but we cannot tell how much more or less they are. There is no basis for belief that the 5 positions indicated on the scale are equally spaced. The interval between strongly agree and agree may not be equal to the interval between agree and undecided. This means that Likert scale does not rise to a stature more than that of an ordinal scale, whereas the designers of Thurstone scale claim the Thurstone scale to be an interval scale. One further disadvantage is that often the total score of an individual respondent has little clear meaning since a given total score can be secured by a variety of answer patterns. It is unlikely that the respondent can validly react to a short statement on a printed form in the absence of real-life qualifying situations. Moreover, there remains a possibility that people may answer according to what think they should feel rather than how they do feel. This particular weakness of the Likert type scale is met by using a cumulative scale which we shall take up later in this chapter. In spite of all the limitations, the Likert type summated scales are regarded as the most useful in a situation wherein it is possible to compare the respondent's score with a distribution of scores from some well-defined group. They are equally useful when we are concerned with a program of change or improvement, in which case we can use the scales to measure attitudes before and after the program of change or improvement in order to assess whether our efforts have had the desired effects. We can as well correlate scores on the scale to other measures without any concern for the absolute value of what is favorable and what is unfavorable. All this accounts for the popularity of Likert type scales in social studies relating to measuring attitudes. Thurstone scale. To overcome terrain problems with the Likert scale, the Thurstone scale was developed. Thurstone scale considers a weight, or attitudinal value for each statement. The weight, which is equivalent to the median value, per cache statement is calculated on the basis of rating assigned by a group or judges. Each statement with which respondents express agreement, or to which they respond in the affirmative, is given an attitudinal score equivalent to the attitudinal value of the statement. Procedure in Thurstone scale. Number 7A. Construct statements reflecting attitudes towards the issue in question. Number 7A. Select a panel of judges who are experts in the field of attitudes being explored. Number 7A. Send the statements of respondents to these judges with a request to rate each statement on 11-point scale. Number 7A. On the basis of the judges' ratings, calculate the median value of their ratings for each item. Number 7A. From the statements, select items that best reflect attitudes towards various aspects of the issue. Number 7A. Construct a schedule comprising the selected items. The Thurstone scale is also called equal happening interval scale. The main advantage of this scale is that, as the importance of each statement is determined by judges, it reflects the absolute rather than relative attitudes of respondents. The scale is able to indicate the intensity of Eppel's attitudes, and any change in this intensity will be replicated. On the other hand, the scale is difficult to construct, and a major criticism is that judges and respondents may assess the importance of a particular statement differently, and therefore, the respondents' attitudes might not be reflected. Stapel scale. This scale was developed by John Stapel. This is a unipolar rating scale with usually 10 categories numbered 4-5 to +5. This scale does not have 0 or the neutral point. Respondents rate how each term describes the object by selecting the appropriate number. Positive number means the term describes the object accurately, while negative number implies that the term describes the object inaccurately. +5 means the highest degree of accuracy, while -5 means the highest degree of inaccuracy. For example, consider the phrases I tasty food, eat fast service, and eat good ambience for a restaurant. A respondent is asked to rate accurately these terms or phrases to describe a specified restaurant: tasty food, fast service, good ambience, +5, +5, +5. +4, +4, +4. +3, +3, +3. +2, +2, +2. +1 +1 +1. -1 -1 -1. 2 2 2 3 3 3 4 4 4 5 5 5. The respondent select +1 for tasty food, -2 for fast service, and +3 for good ambience. This means the respondent thinks that the phrase tasty food is accurate with a minimum degree of accuracy. Phrase fast service is somewhat inaccurate, while good ambience is sufficiently accurate. So according to the respondent, the ambience of the restaurant is good, food taste is okay, but service is slow. This method is applicable when the responses are rated on a single dimension. The method is very economic and data can be collected over telephonic interview also. Some researchers think that the method is confusing and of not much use. Guttman scale. The Guttman scale is one of the most difficult scales to construct and therefore is rarely used. This scale does not have much relevance for beginners or students in RESCARC and so is not discussed in this study material. Here statements of respondents are arranged in a perfect cumulative order, which is rather cumbersome. This scaling technique is also called cumulative rating scale. Semantic differential scale. Semantic differential scale, or the SD scale, developed by Charles E. Osgood, G.J. Suki, and P.H. Tannenbaum, 1975, is an attempt to measure the psychological meaning of an object to an individual. The scale is based on the presumption that an object can have different dimensions of connotative meaning which can be located in multidimensional property space, or what can be called the semantic space in the context of SD scale. This scaling consists of a set of Hippelar rating scales, usually of 7 points, by which one or more respondents rate one or more concepts on each scale item. For instance, the SD scale items for analyzing candidates for leadership position may be shown as under. Candidates for leadership position, along with the concept the ideal candidate, may be compared and we many score them from +3 to -3 on the basis of the above stated scales. The letters, EP, showing the relevant factors viz., evaluation, potency and activity, contributed most to meaningful judgments by respondents. Procedure. Various steps involved in developing SD scale are as follows. First of all, the concepts to be studied are selected. The concepts are usually chosen by personal judgment, keeping in view the nature of problem. B. The next step is to select the scales bearing in mind the criterion of factor composition and the criterion of scales relevance to the concept being judged. It is common practice to use at least 3 scales for each factor with the help of which an average factor score has to be worked out. One more criterion to be kept in view is that scale should be stable across subject and concepts. C. Then a panel judges are used to rate the various stimuli or objects on the various selected scales and the responses of all judges would then be combined to determine the composite scaling. The semantic differential scale has a number of specific advantages. It is an efficient and easy way to secure attitudes from a large sample. These attitudes may be measured in both direction and intensity. The total set of responses provides a comprehensive picture of the meaning of an object, as well as a measure of the subject doing the rating. It is a standardized technique that is easily repeated, but escapes many of the problems of response distortion found with more direct methods. Single multiple category scales. These scales are also known as dichotomous scales. Here we have 2 or more mutually exclusive responses. For example, yes and no, true and false. The respondent has to choose only one out of the given categories. It would be clear from the following example questions of a questionnaire. 1. Do you play cricket? Yes number. 2. What is your marital status? Unmarried, married, divorced, widower. 3. What is your employment type? Salaried, business, self-employed, student. Retired, homemaker. These scales can also be generalized to have more than one response. For example. 1. What do you own? Car, house, computer. 2. What are you interested in? Music, sports. It should be ensured that the provided choice exhausts almost all possible answers of the asked question. The choice others may be given along with other choices. The collected data is on nominal scale. The method is easy and very popular on internet surveys. Full frequency scale. This scale is used when the respondent is unable or unwilling to give the exact numbers in the answer. For example. How often do you eat out? 1. Frequently. 2. Sometimes 3. Rarely. 4. Never. Unidimensional scale. In unidimensional scale, only one attribute of the object is measured. While a multidimensional scale considers that an object is described with several dimensions. For example, the popularity of a restaurant can be measured by a single measure, food taste. It can be defined on multiple dimensions like food taste, service, cleanliness, ambience, etc. Balanced and unbalanced scales. In balanced scale, number of favorable and unfavorable categories are equal, while they are unequal in an unbalanced scale. The scale should be balanced in general to collect an unbiased opinion. However, if the distribution of responses is likely to be skewed on one direction, an unbalanced scale having more categories on the opposite direction is used. Multidimensional scaling. Multidimensional scaling, MDS, is relatively more complicated scaling device, but with this sort of scaling one can scale objects, individuals or both with a minimum of information. Multidimensional scaling, or MDS, can be characterized as a set of procedures for portraying perceptual or affective dimensions of substantive interest. MDS is used when all the variables, whether metric or non-metric, in a study are to be analyzed simultaneously and all such variables happen to be independent. The underlying assumption in MDS is that the respondents perceive a set of objects as being more or less similar to one another on a number of usually uncorrected dimensions. Through MDS, technique 1 can represent geometrically the locations and interrelationships among a set of points. In fact, 3 techniques attempt to locate the points, given the information about a set of interpoint distances, in space of one or more dimensions such as to best summarize the information contained in the interpoint distances. The distances in the solution space optimally reflect the distances contained in the input data. Larger number of scale categories will provide better precision in the collected data. However, it would become inconvenient for the respondent. So, the number of scale categories is a trade-off between precision and convenience. It should be chosen with care. Review questions and exercises. 1. What do you mean by scaling? 2. State the necessity of scaling. 3. Define scaling technique. 4. What are the essentials of scaling? 5. What are the difficulties in scaling? 6. Define a scale. 7. What is nominal scale? 8. State characteristics of a scale. 9. How is scale for a study determined? 10. What are the sources of errors in scaling? 11. Explain situational errors. 12. Give a classification of scales. 13. What is multidimensional scale? 14. What are cumulative scales? 15. Why Likert scale is considered superior. 16. State the basics of Staple scale. 17. What are rating scales? 18. What are ranking scales? Unit 17. Data preparation and processing. The data after collection has to be prepared and processed for analysis. The collected data is raw and must be converted to the form that is suitable for the required analysis. The results of the analysis are affected a lot by the form of the data. So, proper data preparation is a must to get reliable results. Data preparation process. Data preparation or processing is a statistical method by which the collected data is so organized that further analysis and interpretation of the data become easy. Data collected through statistical investigations are complex and unorganized mass of figures. They are not fit for analysis and interpretation. The limitation of human mind to understand such make it necessary to use statistical techniques or process a mass of figures. They are to be provided with a form or structure. Processing is necessary to ensure that we have all relevant data for making contemplated comparison and analysis. According to Mill, the first task of the statistician is an organization of figures in such a form that their significance for the purpose in hand may be appreciated, that comparison with masses of similar data may be facilitated, and that further analysis may be possible. Therefore, data are to be boiled down to make them for digestion. Processing implies checking, editing, coding, classifying and tabulating the collected data so that they are amenable for analysis. The plan of data analysis is decided in advance before collecting the data. Data preparation process is guided by that plan of data analysis. Important steps of data preparation process are as follows: questionnaire checking, editing, coding, classification, tabulation, graphical representation, data cleaning, etc. We below describe each of the above processes. Questionnaire checking. When the data is collected through questionnaires, the first step of data preparation process is to check the questionnaires if they are acceptable or not. This involves the examination of all questionnaires for their completeness and interviewing quality. Usually this step is undertaken at the time of data collection. If questionnaires checking were not done at the time of collection, it should be done later. A questionnaire may not be acceptable if a. It is incomplete partially or fully. B. It is answered by a person who has inadequate knowledge or does qualify for the participation. C. It is answered in such a way which gives the impression that the respondent could not understand the questions. D. If sufficient number of questionnaires are not accepted, the researcher may like to more data. Editing. Editing of data is a process of examining the collected raw data, especially in surveys, to detect errors and omission and to correct these when possible. As a matter of fact, editing involves a careful scrutiny of the completed questionnaires and/or schedules. Editing is done to assure that the data are accurate, consistent with other facts gathered, uniformly entered, as completed as possible, and have been well arranged to facilitate coding and tabulation. With regard to points or stages at which editing should be done, one can talk of field editing and central editing. Field editing consists in the review of the reporting forms by investigator for completing, translating, or rewriting what the latter has written in abbreviated and/or in illegible form at the time of recoding the respondents. This type of editing is necessary in view of the fact that individuals' writing styles often can be difficult for others to decipher. This sort of editing should be done as soon as possible after the interview, preferably on the very day or not the next day or on the next day. While doing field editing, the investigator must restrain himself and must not correct errors of omission by simply guessing what the information would have said if the question had asked. Central editing should take place when all form or schedules have been completed and returned to the office. This type of editing implies that all forms should get through editing by single editor in a small study and by a team of editors in case of a large inquiry. Editor S may correct the obvious errors such as an entry in the wrong place, entry recorded in months when it should have been recorded in weeks, and the like. In case of inappropriate on missing replies, the editor can sometimes determine the proper answer by reviewing the other information in the schedule. At times, the respondent can be contacted for clarification. The editor must strike out the answer if the same is inappropriate and he has no basis for determining the correct answer or the response. In such a case, an editing entry of no answer is called for. All the wrong replies, which are quite obvious, must be dropped from the final results, especially in the context of mail surveys. Editors must keep in view several points while performing their work, but they should be familiar with instructions given to the interviewers and coders as well as with the editing instructions supplied to them for the purpose. B. While crossing out an original entry for one reason or another, they should just draw a single line on it so that the same may remain legible. C. They must make entries, if any, on the form in some distinctive color and the two in a standardized form. D. They should initial all answers which they change or supply. E. Editor's initial and the date of editing should be placed on each completed form or schedules. Coding. Coding refers to the process of assigning numerals or other symbols to answers so that responses can be put into a limited number of categories or classes. Such classes should be appropriate to the research problem under consideration. They must also possess the characteristic of exhaustiveness, i.e., there must be a class for every data item, and also that of mutual exclusively, which means that a specific answer can be placed in one and only one cell in a given category set. Another rule to be observed is that of unidimensionality, by which it is meant that every class is defined in terms of only one concept. Coding is necessary for the efficient analysis and thought that the several replies may be reduced to a small number of classes which contain the critical information required for analysis. Coding decisions should usually be taken at the designing stage of the questionnaire. This makes it possible to precode the questionnaire choices, in which in turn is helpful for computer tabulation as one can straightforward key punch from the original questionnaires. But in case of hand coding, some standard method may be used. One such standard method is to code in the margin with a colored pencil. The other method can be to transcribe the data from the questionnaire to a coding sheet. Whatever method is adopted, one should see that coding errors are altogether eliminated or reduced to the minimum level. Classification. Most research studies result in a large volume of raw data which must be reduced into homogeneous groups if we are to get meaningful relationships. This fact necessitates classification of data, which happens to be the process of arranging data in groups or classes on the basis of common characteristics. Data having a common characteristic are placed in one class, and in this way the entire data get divided into a number of groups or classes. Classification can be one of the following two types, depending upon the nature of the phenomenon involved. Classification according to attributes. As stated above, data are classified on the basis of common characteristic which can either be descriptive, such as literacy, sex, honesty, etc., or numerical, such as weight, height, income, etc. Descriptive characteristics refer to qualitative phenomenon which cannot be measured quantitatively, only the presence or absence in an individual item can be noticed. Data obtained this way on the basis of certain attributes are known as statistics of attributes, and their classification is said to be classification according to attributes. Classification according to class intervals. Unlike descriptive characteristic, the numerical characteristics refer to quantitative phenomenon which can be measured through some statistical units. Data relating to income, production, age, weight, etc. come under this category. Such data are known as statistics of variables and are classified on the basis of class intervals. For instance, persons whose incomes, say, are within 201 to 400 rupees can form one group, those whose incomes are within 401 rupees to 600 rupees can form another group, and so on. In this way the entire data may be divided into a number of groups or classes, or what are usually called class intervals. Each group of class interval, thus, has an upper limit as well as a lower limit, which are known as class limits. The difference between the two class limits is known as class magnitude. We may have classes with equal class magnitudes or with unequal class magnitudes. The number of items which fall in a given class is known as the frequency of the give class. All the classes or groups, with their respective frequencies taken together and put in the form of a table, are described as group frequency distribution or simply frequency distribution. Classification according to class intervals usually involves the following three problems. How many classes should be there? What should be their magnitude?